Welcome students. Today we are going to discuss about 80387 NDP numeric data processor. It is a coprocessor which is used for doing the mathematical calculations associated with the program. All the instructions of this coprocessor start with F, as you already know. 80387 works with 80386DX and together they do the operations of the program. So today we are going to discuss about the features of 80387, control register bits of the coprocessor, 80387 register stack and data types, and some instructions of 80387. So speaking about the features of 80387, it is a high performance 80-bit architecture. So it supports 80-bit architecture 80387. It supports binary floating point arithmetic. So binary floating point arithmetic operations are supported by 80387. The data types of 80387 are 32, 64 and 80-bit. It has 80-bit data registers organized in a 8 register stack. Each register in the 8 register stack is 80-bit. It supports trigonometric instructions, logarithmic instruction, exponential, arithmetic instructions for all data types. So a lot of instructions are supported by 80387 and all of the instructions start with F, like F add, F div, F sub. These are some of the examples of arithmetic instructions of 80387. You also have F sin, F cos. So these kind of instruction that are transcendental instructions are also supported, that is sine, cosine, tangent, logarithm, etc. It has built-in exception handling. So that is another feature of 80387. It has built-in exception handling. And as I told you, it has 8 80-bit numeric registers arranged in a stack. Speaking of the register set of 80387, it has data registers which are 8 80-bit registers arranged in a stack, which is having a top of the stack and the remaining registers. So the stack registers are 8 80-bit registers. Then it has a tag word. Tag word is a 2-bit part of the data register of the stack. Then it has a status word. It is a 16-bit register. It gives the overall state of the 80387. It has instruction and data pointers. Two pointer registers allow identification of the failing numeric instruction. So it gives the address of the failing numeric instruction and the address of the numeric memory pointer. So this instruction and data pointer registers, they give the address of the instruction which has failed and the address of the operand of that instruction. Then it has a control word which can give various options for controlling the 80387. So this is the 80387 status word format. As I told you, it is a 16-bit register status word of 80387. It is having exception flags, precision, underflow, overflow, zero divide, denormalize operand, and invalid operation. These are all exception flags of the 80387. Then it is also having error summary status bit and stack flag. Another thing that you can do in this status flag is that the top of the stack can be mentioned in the status flag. It gives the top of the flag top of the stack of its 8-bit stack register stack that 80387 has. So this top 3 bits, they give the which register is the top of the stack. If it is having value 000, register 0 is top of stack. If it is having value 001, register 1 is top of stack, and so on. So the top of the stack is mentioned in this status register in the 3 bits. So this is about the status register of 80387. So these are the details of the status register or status register of the 80387. Bit 15 is the busy bit. It is used for compatibility with 8087. Bit 13 and to 11 give the top of the stack. So it gives the register that is the top of the stack. The stack has 8 registers. Each register is 80 bit, and which register is the top of the stack is given in these 3 bits. Then bit C0 to C3 are numeric condition code bits, and they're similar to the flags in a CPU. Bit 7 is the error summary bit. It is set if any unmasked exception is there. Bit 6 is the stack flag SF bit. It is used to distinguish invalid operations due to stack overflow if it is 1 and underflow if it is 0. Bits 5 2 to 5 are exception flags of the coprocessor. So these are some of the details of the 80387 status register. So this is the format of the control register of 80387. This is also a 16-bit register. It is having exception mask, as you can see in the diagram. Exception masks are precision mask, underflow mask, overflow mask, zero divide mask, denormalized operand, and invalid operation. So you can set these exception masks using this control register. So this is useful for controlling the exceptions of the 80387. The other bits of the control register are PC, precision control, and rounding control. Precision control has 2 bits, rounding control has 2 bits. Precision control, when it is 00, it is a 24 bit. It is single precision when it is 00, precision control. When it is 01, it is reserved. When it is 10, it is 53 bits double precision. When it is 11, it is 64 bit extended precision. Similarly, you can control have a rounding control. When it is 00, it is round to nearest or even. When it is 01, it is round down. When it is 10, it is round up. And when it is 11, it is chop, truncate towards 0. So this is the 8 register stack of 80387. It is having 8 register. Each register is of 80 bit, as you can easily see in the diagram. Top of the stack is given in the status register, which register is currently the top of the stack. Each register is 80 bit, having sign, exponent, and significant part, and it has a 2-bit tag value. Tag values can be 00 valid, 01 when it is 0, and not a number, and all those other bits, all the values can be for 10. So the operations of the instruction normally start from the top of the stack, and the remaining registers are accordingly given values after the top of the stack. Like for example, if you have FLDZ, Then 0 will be copied into the top of the stack, whichever register is the current top of the stack, that register will have 0 value loaded into it. So many instructions of 80387 by default take top of the stack for their calculation. Now for example, if R0 is the top of the stack, status register will have top of the stack bits as 000, and the remaining registers will be accordingly the next registers in the stack. So ST0 will be R0, and then you will have ST1, ST2, ST3, ST4 and so on. So as per the top of the stack, accordingly the other registers are taken in sequence. You can directly access different registers. Like if you want to access the fifth register, you can say ST5 and you can access the fifth register. If you want to access the second register, you can say ST2, and as per the current top of the stack, the next registers will be taken in sequence. Then speaking of the data types of 80387, we have word integer, which is a 16-bit data type, short integer, which is a 32-bit data type, long integer, which is a 64-bit data type, packed BCD, which is 18 digits, single precision, which is 24 bits, double precision, which is 53 bits. So these are some of the data types of it. We also have extended precision, which is 64 bits. Speaking of the instructions of 80387, these are some of the data transfer instructions of 80387. FLD, load real. It loads the operand into the top of the stack. FST, store real. It copies the top of the stack value into the operand. FSTP, it copies the top of the stack value into operand and also pops the top of the stack. FXCH, exchange register. FILD, integer load. It loads integer operand into top of the stack. FIST, it stores the top of the stack into the operand, but integer value is copied. FISTP stores the top of the stack value into operand, integer value, and also pops the top of the stack. Then FBLD is packed decimal BCD load. FBSTP, packed decimal BCD store and pop. So you can easily see many instructions of 80387 use the top of the stack in their execution. So these are some non-transcendental instructions of 80387. Addition has fadd, faddp, fiadd. Subtraction f sub p, fi f sub r. These are some subtraction instructions. Again, if you only give f sub, st0 will be subtracted from st1 will be subtracted from st0. If you give only f add, st0 and st1 will be added and the result will be stored in st0. If you give f mul, st0 will be multiplied with the operand if you give it with the operand multiplication. So multiplication is f mul instruction, division is f div. There are some other operations like f sqrt, f scale, and so on. So these are some of the 80387 instructions that you will use some of it in the programs. So I hope the video has cleared some of the concepts of 80387, which will not only be useful for you in the theory but also in the practical programs that you will be writing for 80387. Thank you.